In this video, we will go into the basics of vector algebra. I will use very simple illustrations for you to understand, and we will, in the further videos, we would have also covered, deeper subject of vector algebra. But first, the basics, the very foundations, and they're very simple. And I'm going to give you very simple illustrations to make you understand. And if you have not subscribed to the channel, please kindly subscribe so you will get more of these videos as we update them. So let's get into the topic. So vector algebra is nothing but just direction. I'm sure you all have your smartphones and you're using it when you go to cities, and you go to different places to identify locations. You use a smartphone to the GPS to track down a certain area, a certain place, certain house, or a hotel or a facility. And you'll always find that the GPS, when you turn it on, it will start to tell you, go another 500 meters, turn left, and keep the first lane, and then go, in another 200 meters, turn right. And so it will keep giving you a direction and the distance, right? So we have all experienced that. I'm sure that, you're very familiar with that. Or, let me make it more easier for you. If, let's say this is your school and that's your home. So after school, we all love to go back home. So how do you go back home? You go straight in this direction, and then you turn left and you go like this, and then you turn right and you go like this. All right? So as a kid, I had problem with left and right, but thank God now I'm able to, explain it to you better. So I know some of us have difficulty, but vector algebra is all about direction. All right? So if you're starting from home and going down this road, you cannot keep going straight. You need to turn at this point. So if you have to give the direction to somebody who doesn't know the route, you have to tell him you need to travel this particular distance, and you have to turn left, and you have to go in this distance and take, the right. So you need to give them the direction, which direction to go. If you had many roads, in the other directions, you have to tell them to go in this direction and then turn left here and turn right here. So direction is something that's very important when we navigate. And second thing that we have to keep an eye is how much distance we have to go before we turn the direction. So the length of this road or this segment is defined. Let's say this is 500 meters, 600 meters, and 100 meters. So they are defined with a certain magnitude or length. So this is called magnitude. So vector algebra deals with arrows like this. Don't get carried away with them. They're just showing you the length and direction, right? I hope I made it very simple for you. Now let's proceed. Now let's consider, I've just taken the same route, from the school to your home, and I have plotted it here, and I'm giving them points. I put it on an XY plane, and I'm calling the starting point as A, where your school is, and I'm going to call this point where you have to turn left as B. So I'm going to call this length as vector A. So what does this vector illustrate? The direction that you have to go and the distance that you have to go. So I'm going to mark it as A, vector A is equal to AB. So starting point is A, end point is B, and it's a directional vector. It is directional. Same way, you can have other vectors BC and CD. So the point A is called the initial point of this vector, and the point B is the final point. Just note my, the emphasis that I'm giving on initial and final. They're not endpoints. They're not a straight line with endpoints. They're directional. You have to move from here to there. So there's an initial point and there's a final point. All right. Now, you see the same vectors, which is AB, I've just thrown them all over the place. So what are they? Vectors, when they're not specified in a certain location, but they are bound by two things. One is the direction and the length, how long it is. All right. So when you define a vector like this AB, but it's not placed in a certain place, these are called free vectors. All right. But if you have to space them in a, plot them on a certain location, then they become localized vectors. Right? So I think that's getting more easier now. So a vector can be plotted on any place. It's like you can carry them around, but the nature is they maintain the same direction and the same length, and the name doesn't change. It is the vector AB. Even if I'm going to move it around here and there, it's a free vector, but its length is maintained as AB and its direction is maintained in this direction, right? Next, co-initial vectors. So when you have vectors starting from one point and going in different directions, you have three vectors here, vector A, vector C, and vector D. Now, you notice they're all starting from the point A. So, such vectors are all called vector A, C, and D can be called co-initial vectors. Similarly, if all the vectors are going to a certain point, C, right? So their end point is all C. Vector A, vector C, and vector D is all ending at C. These vectors, A, C, and D, are called co-terminous vectors. Now, consider two vectors, vector A and vector B, right? You will notice that they are in the same direction. They're parallel to each other. So they have the same line of action. They have the same line of action. Such vectors are called collinear. And coplanar vectors are vectors that are in the same plane and they are parallel to each other. And we will get more into coplanar as we go deeper into the topic. Right. Two vectors can be called equal vectors if they have the exact same width. A and B are equal in length and their direction is exactly same. They're going, parallel to each other. Then these vectors are called equal vectors, right? So they have the same direction and the same magnitude. Next, let's go to zero vector. If there is a vector that has no direction, or you can call that as arbitrary direction, and it has no length, it's like a point, then it's called a zero vector. So it has zero magnitude and an arbitrary direction, and they can be denoted as zero vector on top. They are also called null vector or void vectors, right? Next, unit vectors. Vectors are very, very useful in, when you go into so many applications in physics with force, and there's so many of these, physics that what you study would be interlinked with vector. So I'm sure that, this study would help you to lay a good foundation. Now let's go to unit vector. Unit vector means it's got just one unit length. If it's say 1 kilometer, it's 1 unit length, or it can be 1 meter, can be 1 centimeter. So the length is 1 unit, right? So and this is represented with a cap like this. And if I'm going to take the mod of this, it's going to be equal to 1, right? Next, we'll see what are like vectors and unlike vectors. With this, we have covered this section today. Like vectors are two vectors which are going in the same direction, right? And unlike vectors or vectors who are in the exactly opposite direction. So when you say unlike vectors, remember this, they are not random, but they're exactly opposite to each other. And these vectors can be called neither like nor unlike vectors. So with this, we will end today's this study on the basic of vectors. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.